This is Topic 3 review for Algebra 1. How can linear functions be used to model situations and solve problems? Well, when we have bivariate data, we can graph it on a scatter plot. So bivariate data can be plotted on a scatter plot. And if there is a linear relationship, like a correlation, either positive or negative, so positive, negative correlation, you can find a line of best fit. And this works with real-world situations like the temperature after the sun setting, or maybe the amount of mosquitoes there are after a rainfall. These sort of things where we're comparing two things to see if there's a relationship. Number 2, when y tends to increase as x increases, the two data sets have a positive association. A blank is the difference between an actual and a predicted data value, and that is this one, residual. A blank is an ordered list of numbers that often forms a pattern, a sequence. A trend line that most closely models the relationship between two variables displayed in a scatter plot is the line of best fit. The blank measures the strength and direction of the relationship between two variables in a linear model. That would be the correlation coefficient. For each of these sections that we learned, Lesson 3.1, Relations and Functions, and as we move through the review, there will be other sections. I think it's important for you to read this part on your own. So when you're studying at home, you can read this section. Right now, I'm going to go over the questions that are going to closely relate to what will be on the test. So I'm going to do number 7 and number 8 to start. It asks us to identify the domain and the range of each relation. Then they're also asking us, is it a function? Yes or no? So for number 7, the domain is going to be all of the x values. So 4, 2, 0, and 5. The range is going to be 1, 3, 4, and 3. And then it's asking, is it a function? And for this one, I see that the 4 goes to the 1, the 2 goes to the 3, the 0 goes to the 4, the 5 also goes to 3, so we don't actually need to write that 3 again. And if we draw arrows, the 4 goes to the 1, the 2 goes to the 3, the 0 goes to the 4, the 5 goes to the 3. Well, it is a function because the domain does not repeat. The range has a repeating value, but the domain does not. So yes, it is a function. A function. I'm just going to abbreviate it because I don't have a lot of space here. On number 8, the same thing, we're asking for the domain and range. So the domain is the x values, -1, -5, 4, 0, 2. The range is -5, -2, 0, 3, and 2. And none of the domain values repeat. So, and none of the range values do either. So it is a function. Because the domain values do not repeat. All right, we're on to section 3-2, linear functions. And I think this is probably the hardest section because we have to go back to y equals mx plus b, but instead of y, we're using f of x. Okay, so f of x. I want you to read this part and study that as you review. For this section, we're going to do just number 15. Melissa runs a graphic design business. She charges by the page and has a setup fee. The table shows her earnings for the last few projects. What is her per page rate and what is her setup fee? So we're looking for her per page rate, we're looking for her setup fee. And this is going to be a linear function because that's what we're learning right now. And also, we're going to want to make sense of this problem and persevere in solving it. Think about, like, if you were to design a poster, you would charge, like, if there was one poster, you would charge a certain amount. If there were 2 different posters, you would charge a certain amount. So that's what her business is. She's designing pages. The amount of pages determines the cost. So this table is set up a little different where this is our x, and normally we have our x on the top, but this problem's just a little weird in how they set it up. And then this is our f of x or our y, right? Like f of x and y are synonymous. They mean the same thing. Since we're learning linear functions and we just had this equation that we've been working with, f of x equals mx plus b, that's what we're going to use to solve this problem. All right, so we'll write over here on the side, f of x equals mx plus b. And you can write that on your paper. First thing we need to do is figure out the slope. The slope is the change in y over the change in x. I'm going to choose these 2 points just because the subtraction is a little easier. So the y values, and like I said, this table's backwards from what it normally would be. It would normally have pages on the top and cost on the bottom. But we put the y, or the f of x, on top, change in y, over change in x. So that's going to be 300 over 4. If you do that in your calculator, you get 75. That means that every new page is going to cost $75. She also has a setup fee. So if she was going to just do one page, you would subtract 75 to go backwards in this table. You could subtract 75 twice to get to 0. The other way to do that is to plug this in to y equals mx plus b, but I kind of wanted to show you like the easier way to do it. Instead of plugging it into mx plus b, what's 185 minus 75? 110. So it's $110 for one page. subtract 75 again, and let me think. I think you get 35. So for 0 pages, just to like set it up, it's $35. That's my B, because I subtracted 75 each time. So if you added rows to the table or columns to the table, you could get backwards to 0. That works when we have nice numbers like this. So f of x is equal to 75 per page, so that's 75 times x, plus a $35 setup fee. So see how putting it into this equation answers our question, answers the real world question. So it's $75 per page. It's a $35 setup fee. And that's that problem. And you may have one like that on the test. That's why I'm going over these specific problems. All right, we skipped section 3-3, so on to 3-4, arithmetic sequences. For this section, I want you to read the quick review, and I want you to read this example. Let's go over numbers 27 and 28. You'll also need to tell whether a sequence is arithmetic or not. So you may want to do these ones on your own later if you don't know how to do that. A table of data of an arithmetic sequence is shown. Use the explicit formula for the arithmetic sequence to find the 15th term. So explicit is the formula for explicit is a sub n equals a sub 1 plus n minus 1 times the difference. And the poster will be up in the board for you when you're taking the test, but this you can also use your notes, and this would be good for you to have in your notes and know that this is the explicit formula. So the first term is given to us. This is a sub 1, right? A sub 1 is the first term, and the x is 1, so it's first term. That's going to be 8. So that's going to go in, the 8 is going to go in the formula right here. Then we have n minus 1, and that just stays n minus 1. And then we need d, which is the difference. So d is our difference. What is this arithmetic sequence changing by? What are we going up by each time? Because we are definitely going up. And we're going up by 5. So the common difference is 5. That's going to go in the formula. Okay? So from here, we're going to write a sub n equals 8 plus n minus 1 times 5. Then the next question, that's the explicit formula, so that's half of the problem, finding the explicit formula. The other half of the problem is finding the 15th term. So we need to plug 15 into n. So we just rewrite the formula, plus, instead of n, we put 15 minus 1 times 5. And then we use order of operations. 15 minus 1 is 14. 14 times 5 plus 8. So we do the multiplication first. That's going to be 70 plus 8 equals 78. For number 28, Gabriella is selling friendship bracelets for a fundraiser. After the first day, she has 234 bracelets left. So she's selling them, and now she only has 234. That's on the first day. On the second day, she sold some more, so she has 222 left. Assuming the sale pattern continues and it's an arithmetic sequence, how many bracelets will she have left to sell after the 5th day? Okay, so let's write the recursive formula for this one, and then we'll write the explicit formula. So for the recursive, it's the first day, 234. Then the recursive formula is a sub n. So I'll write right here, recursive. A sub n equals a sub n minus 1 plus the common difference, but the common difference is a negative, so I'm going to put a minus. It goes from 234 to 222. So it's looking like if I subtracted those two, 234 minus 222, I get 12. So she's selling 12 each day, so she has 12 less every time. All right. The explicit formula is a sub n is equal to the first term, which is 234, plus n minus 1, and the common difference is negative 12. Since it's negative, I'm going to put it in parentheses. For the 5th day, after the 5th day, we want to know how many she has left to sell. So let's plug in 5 to the explicit formula. 234 plus 5 minus 1 times negative 12. So 5 minus 1 is 4, and 4 times negative 12, I'll just write it out for you. 4 times negative 12 is negative 48, and we have 234 plus negative 48. Since we have a positive and a negative number, we need to subtract those. So I'm going to do my scratch over here to subtract 48. And I need to borrow, so this becomes 14. This becomes 2. 14 take away 8 is 6. I can't do 2 take away 4, so I'm going to borrow. It becomes 12. And the 2 becomes a 1. 12 take away 4 is 8. Bring down the 1. So after the 5th day, she has 186 bracelets left to sell. Section 3-5 is about scatter plots and lines of fit. You should read this review, and you should read over this example on your own. For this section, we're going to cover problems 29 and 30 because there will be questions like that on the test. And we'll also do question 34. Okay. For problem 29, it asks you to describe the type of association. For 29, there is no association, no correlation. For number 30, you could draw a line of best fit, something like this, and that would be a negative association. Oops, spelled that wrong. Association. Okay, so for problem 34, you could use the calculator for this one, but technically when we learned this section, we didn't quite have the calculator yet. So we're modeling with mathematics. The table shows the recommended distance of a light source, Y, in feet from the wall for different ceiling heights in x in feet. What is the equation of the trend line that models the data shown in the table? What does the slope of the trend line represent? So let me think about what this means. The distance of a light source in feet from the wall for different ceiling heights. So this is like interior design. So from the wall for different ceiling heights in X feet. So what they're saying is that your light source or your lamp should be a certain distance away from the wall depending on how tall your ceiling is. So if your ceiling if your ceiling is 8 feet high, then your light should be 20 feet away from the wall. And if your ceiling is 9 feet, 27 feet from the wall. And so forth. So, whether or not we understand exactly what that means, we're not necessarily interior designers, we can still plot the data. And all the numbers are positive, so I'm going to make a graph in the positive quadrant, and I'll give you graph paper for this. So we have 8 to 12 in our x values, and that's the ceiling height. So I'm going to count by twos. Till I get to 12. And then we go from 20 to 48. I think I'm going to count by tens, but I'm going to leave a lot of space. So 10, 20, 30, 40, 50. Those are my y values, and those are distance of a light source from the wall. Like I said, whatever that means. I'm not an interior designer. But I'm going to plot these points. So I'm going to go to 8, 20. That's right here. And then I'm going to go to 9. So in between 8 and 10. I'm going to go up to 27. Then I'm going to go to 10, 33. I'm going to go to 11, 40. I'm going to go to 12, 48. So I have a pretty good line here. It goes through most of the points. So what is an equation of a trend line? So I'm just kind of guessing a line that represents the data in the table. So the y-intercept is going to be a negative number, which is kind of weird, but we're going to go with it. What does the slope represent? So the slope, we can find that, kind of guesstimate it from 2 points. I'm going to pick a point that is not in our data but is on the line. So maybe this point right here, and I'm going to call that 10, 30. And then I'm going to pick another point right here, which I'm going to say is 13, 50. I'm going to find the slope by subtracting the y's. So 50 minus 30, finding the slope, over 13 minus 10. That's going to give us 20 over 3, which is, let's see, 3 goes into that 6 times, so it's 6.6 repeating. That's my slope. What that means is for every 1 foot for every 6.6 repeating feet of ceiling height, you're going to place, I'm thinking this wrong, you're going to place the light source 6.6 repeating away from the wall for every foot in height of the ceiling. Okay. What is the equation of the trend line? We need to plug 6.6 repeating, or maybe the fraction might work better. It also equals, we could just leave it as 20 thirds. Okay, so for every 3 feet of ceiling height, it's 20 feet away from the wall that you want the light source. All right, let's plug this into y equals mx plus b so we can figure out what the b is. So I'm just going to use the 20 thirds because it works a little bit nicer. And then I'm going to use this point because of the 33. Or the 10 and the 33 I think are going to work nicely with the 20 thirds. So we're going to use I'm going to change my mind. We're not going to use that point. We're going to use the point that we came up with. We're going to use this point here, 1030. So x is going to be 10 plus b, and y is going to be 30. And 10 times 20 is 200, so we have 200 divided by 3 plus b equals 30. Then we have to subtract 20 over 3 from 30. So I'm going to do that over here in Scratch. 30 minus 200 over 3. Well, I can find a common denominator, right? Like if I multiply 30 times 1, but I'm going to multiply it by 3 over 3 because 3 over 3 is 1. I still get 30. It's just going to look different. 30 times 3 is 90. So 90 over 3 minus 200 over 3 is equal to 110 over 3. That is my B. So I said, like, this is one of the harder sections because we're having to write lines. This is what our B equals. And this is what our M equals. And now we can write our equation. Our equation, where am I going to write it? I'm out of space. Y equals 20 thirds x plus 110 thirds. That is the equation for our trend line. And then we need to answer, what does the slope mean? What does the slope mean? So the 20 is our y's. So for every 20 feet, I'm writing this backwards. We want to talk about the feet away from the wall. And so x's are on the bottom. So I'm sorry, for every 3 feet in ceiling height, the light source is 20 feet from the wall. For section 3-6, we were analyzing lines of best fit, and this is where we use the calculator. So I want you to read the quick review on your own, and I would like you to do this example, like read through this example on your own. We're going to do numbers 36 and 37. 36, practice and problem solving. Use technology to perform a linear regression to determine the equation for the line of best fit for the data. Estimate the value of y when x equals 25. Since most of you probably don't have the TI-84, I'm going to show you how to do this with Desmos, just because I don't have a TI-84 right now when I'm recording this video. So we're going to remember these numbers, and we're going to put them in Desmos. I'm going to take a picture of it with my phone so I remember. And then I'm going to go to my Desmos app. And I'm going to put these, I'm going to add a table. So in the calculator that I've shown you, you go to Stat. And you put them in the table like that, Stat Edit. In Desmos, we go to the plus button. Just putting in all my x values. And then I'm going to put in my y values. Okay. Then we're going to, since we have y sub 1, we're going to type in y1. And we're going to use the approximation. Is that in our functions? I don't see it. All right, it's kind of difficult to find. It's this. There it is. It's that little tilde, and if you're doing it on the computer, it's the upper left on your keyboard, the approximation. And we want it to be close to m for slope, and then we want it x1. And that gives us a line through these data points. But I'm not seeing the data points, and I think it's because I'm not zoomed out enough. Let's turn them on. There they are. Interesting, that line definitely does not go through our points. So let me check the video that I watched on how to do this again. Pause the video now while I figure. Okay, so all I left out was the plus b. And now it goes through. Awesome. And this is just like on your calculator. You have the m, which is negative 0.93 repeating, and you have the b, 91.4. Let me see again. 93 repeating. So y equals negative 0.93 repeating x plus, I think it was 91. Let me check. 91.4. And then we need to estimate when x is 25. So we're going to plug in x into the x, 25. So negative 0.93 times 25 plus 91.4. And you can do that in a calculator. So negative 0.93 times 25 is negative 23.25 plus 91.4. That equals 68.15. So when x is 25, y is 68.15. And you'll have one of those on your test. Number 37, how are interpolation and extrapolation similar? How are they different? Well, interpolation and extrapolation both predict values within the data set, or values from data. Interpolation gets the data from or is predicting it within the data, and extrapolation is outside of the data. So I for interpolation is within or inside the data. For example, like on number 35, if I picked a number like 23, that would be interpolation. Extrapolation is outside the data. And that would be like if on number 35 I picked like 50, because 50 is not within the data. And that completes our review for our topic 3.